Welcome to Craft Guru Education. This is video number 3, Form 4 Chemistry. Let's continue the discussion of how to write chemical equations. Before that, I would like to share my screen. This is the handout. Have you submitted your request via our Google form in the description? Remember to like, subscribe and share our YouTube channel. From video 1, we talk about atomic structure, moving on to electron configuration, and then we talk more about electron configuration in video 2, and end it with writing the ionic compound, the formula for ionic compound. Today, I will start the recap of writing ionic compound, followed by how to write chemical equation. We will look at how to write the formula for ionic compound again. As you can see from the screen, the formation of positive ions, metals that have valence electron numbers of 1, 2, and 3 form positive ions. Why they form positive ion? Because they want to achieve stable electron arrangement of noble gas. Noble gas, they are sane, they have achieved stabilization, and they don't want to take part in chemical reaction. But metal, they haven't achieved stabilization like noble gas, so it has to turn into positive ion. So if we were to give reason why metal become positive ion, it is because they want to achieve stable electron arrangement of noble gas, because people won't know what is stable electron arrangement. So if we give example of noble gas type of electron arrangement, then people understand. Therefore, positive ions is formed. An example of drawing how sodium from less stable to stable with positive charge look like this. Let me draw the electron configuration for sodium. This is how we draw it. Sodium with the atom, the nucleus in the middle. The shell number 1 with 2 electrons. We use cross to represent the electron. And then we have 8 electrons in shell number 2. Last but not least, the third shell will have 1 valence electron. This is not stable. It is atom but not stable. To achieve stable electron arrangement like a noble gas, sodium will donate this electron and turn into positive charge. So this is the electron arrangement of, so donate this electron out and it becomes like this. Sodium nucleus, shell number 1, shell number 2, 1, 2, 1, 2, 3, 4, 5, 6, 7, 8 with a plus outside. This is how we draw the formation of positive ion for sodium. Next, let's look at the formation of negative ion by using the example of chlorine. Chlorine, they receive electron to achieve stable electron arrangement of noble gas. Example, chlorine from less stable to stable with negative charge. Chlorine starting from the nucleus again. Chlorine 1, 2, 3. So this time I'm going to use dot to represent electron for chlorine. 1, 2, 3, 4, 5, 6, 7, 8. And chlorine has 7 valence electrons. 1, 2, 3, 4, 5, 6, 7. It is not stable. It needs to receive 1 electron. Where chlorine get this electron from? We assume sodium is donating the 1 electron to chlorine. So we draw the new atomic structure like this. Still 3 shells. This is chlorine. The symbol we write at the nucleus. 1, 2. The second shell has 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. The third shell has 7, but receive 1 from sodium. So that one is a cross. I draw cross with negative charge. This is how we draw chlorine from less stable to stable with negative charge. Sodium react with chlorine. Chlorine, as we learn, is non-metal. Non-metal normally has to be molecule. Sodium and chlorine. Sodium, the nucleus, the first shell, 1, 2, second shell, 1, 2, 3, 4, 5, 6, 7, 8. The last shell, 1. And this one is being donated to chlorine. We draw chlorine here. 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. And the last one. 1, 2, 3, 4, 5, 6, 7. And this 1 electron came over to chlorine. Making sodium become 1 positive charge. Come here. Making chlorine become 1 negative. All right. From this example, let's learn how to write chemical equation for the reaction between sodium and chlorine. We know that the chemical reaction is between sodium and chlorine to become sodium chloride. Now we are going to write the symbol. Sodium, what's the symbol? Yes, we know it is Na. So we ask ourselves, is sodium metal or non-metal? Yes, we learned that it is metal. It has to be alone. So just write the symbol, Na will do. Next, chlorine, the symbol is Cl. Now we ask ourselves, chlorine is metal or non-metal? Yeah, we learned that it is non-metal and it has to be in the form of molecule. So we put Cl2. Bear in mind that when this element want to have chemical reaction, it will become ion temporarily. Sodium will become Na plus temporarily. Chlorine will become Cl minus temporarily. We ignore the 2 for now. So 1 positive react with 1 negative, it will become 1 sodium enough, 1 positive ion of sodium enough to neutralize 1 negative ion of chlorine. Basically, this is how we write chemical equation. But if you look at it, it's like not equal, not balanced. Suppose we have 2 atoms of chlorine. Now on the right hand side become 1. So to write a balanced chemical equation, we need to now think how to balance chlorine. On the left hand side, we have 2 chlorine. On the right hand side, we need to balance it. We write the 2 in front of the whole compound, like this. We cannot write the 2 here. This will mean that 1 sodium react with to have 2 chlorine ion combined with it. So we cannot write the 2 at the bottom. We write the 2 in front. Let's check. 2 chlorine balance. But this 2 is also shared to sodium. Here on the left side, we only have 1 sodium. For sodium, it is not balanced. How do we balance it? We add the 2 in front of sodium here. And that gives us a balanced chemical equation. Let me summarize the correct chemical equation. It is 2Na plus Cl2 become 2NaCl. Easy, right? I will use one animation to represent the whole chemical reaction. This is the animation. At first, we have 1 sodium. Sodium is metal, so single atom. Chlorine is non-metal. It is in the form of molecule. Therefore, you see 2 chlorine on the screen. When chemical reaction happens, that 1 sodium atom will donate 1 electron to chlorine and it becomes positively charged. When chlorine receives that electron, it becomes negatively charged. So the positive ion attract the negative ion, they combine together. But what happened to the other chlorine? Still alone. We need another sodium atom to come and donate the electron to this chlorine. And finally, they attract each other. That's why you see the formula at first 1 sodium, 1 chlorine molecule. At the end, become 2 sodium chloride. And we need to balance sodium because on the left side only have 1, and you notice we have 2 sodium here come out to give charge to the chlorine molecule. And you should understand why we have 2 sodium atoms. We read like this: 2 sodium atoms react with 1 chlorine molecule to form 2 sodium chloride ionic compound. Or, in a proper term, we say 2 mole of sodium react with 1 mole of chlorine, understood is molecule, to become 2 mole of sodium chloride, and understood its ionic compound. I hope this animation gives you a clear picture. To practice how to write chemical equation, let me give you another example. A chemical equation for aluminium with oxygen. We will look at the name later. Recall aluminium is metal. It is single atom. Oxygen is molecule, non-metal, O2. When they want to have chemical reaction, temporarily aluminium will become Ai3 positive and oxygen will become 2 negative. We ignore the molecule for now. We just think of the ion, the form of the ion. So the aluminium and oxygen will exchange number like we learned earlier, the shortcut. And the ionic compound will have this formula, Al2O3. Now it's time to balance the equation. On the right side, you see we have 3 oxygen. On the left side, we have 2 only. So what is the common factor of 2 and 3? We know it's 6. So how to make the right side oxygen become 6? We add a 2 in front. So 3 times 2 is 6. For the left side, we add a 3 in front. So 3 times 2 is 6. This will give us a balanced number of oxygen on both left and right side. Finally, we balance the aluminium. 2 times 2 is 4. So left side, we add a 4 there. Okay, the easy step to write chemical equation, I will summarize on the screen now. Step number 1, for the left side, we start from the left-hand side first. We will write the symbol for metal. It is atom. We write the symbol for non-metal. It is in molecule. Then we write the temporary ionic, the ions for both positive and negative. Ignore the molecule, whether it's O2 or O3. We just write the ions first. After that, we start writing the right-hand side, followed by right-hand side. How the 2 ions balance each other. Finally, we balance the equation by adding number in front of the element. So follow this step, you should be able to write a balanced chemical equation. Let me delete this so that you can see my summary here. Simple. If you want to try more, my handout have more questions for you to practice. Here we have a few equations here for you to write. So if you have any questions, do contact us in our YouTube channel. Like, follow, or subscribe and share our video. That's conclude our video 3. In video 4, we talk about moles, how to do calculation. Of course, I can give you more example of how to write chemical equation between metal and compound or non-metal and compound, and then we look at the calculation of moles. That brings us to a more exciting part of chemistry. See you in video 4.